Okay, fellas, the other one that I thought you were going to have problems with is the projectile motion one. Let me bring it up real quick. This is the one I thought you would probably have a problem with. It's a projectile motion that's being fired at some velocity, at some angle, and it asks, how high does it go? How long is it in the air? Determine how far it goes, and determine the speed after a certain amount of time. Okay, so let's do something similar, okay? So, say you shoot something in the air, has a velocity of 23.4 meters per second, and you shot it at some angle to the horizontal of, I don't know, let's say 45 degrees. Okay, now this thing is going to fly up, come back down. Okay, one of the things it wants you to do is figure out how high it goes, figure out how far it goes, and how much time it's in the air, and then we'll figure out the velocities at different times, okay? So, first thing is, let's calculate how high it goes, yeah? Okay, so before you do anything, what you want to do is break this, this velocity up into a horizontal and a vertical portion, okay? So the vertical portion of that velocity, remember, is going to be 23.4 and sine of 45. You know what? I don't like the angle I chose because it's going to make both of these things the same number. Let's switch the angle to like 40 degrees or something. Okay, so this is going to be 40. Okay, and then let's do the horizontal. So Vx will be 23.4, and it'll be with cosine of 40. Okay, so first off, let's figure out what these two things come out to equal. 23.4 times cosine of 40 is 17.9. And the other one here is 23.4 times sine of 40, and it comes out to 15. Okay, and these are both meters per second, okay? Okay, so that's the first thing you got to do. And then remember, you want to break these up, okay? Break these up into two different categories. You're going to have your vertical stuff, which I'll do in green. And you're going to have your horizontal stuff, which I will do in red. Now remember, with the horizontal stuff, you can use the big three formulas. I mean, the vertical stuff, you can use the big three formulas. And then on the other one, the horizontal, you're pretty much only going to be using the second formula is the only one that really works for it. And we can talk about why right now when we get to it, okay? But let's write down our knowns. So on the vertical stuff, I know my initial velocity is going to be 15. And it's in the positive direction, right? So that's why I put it as positive. One thing I do know, up at the top, the velocity at the top is equal to 0. Yeah? Then let's do this. The next thing that you want to do is write down like the acceleration. Remember, it's negative 9.8. Okay, and then I'm trying to think of anything else that we know here. I know my initial position here. It starts at the floor, right? My initial position is 0. Okay, that's pretty much everything I know. And then on the horizontal, let's write down our horizontal stuff we know. We know the initial velocity is 17.9, and actually that's the only velocity because it doesn't change, right? The velocity doesn't change as it flies. The velocity horizontally is always going to be 17.9 everywhere. So I know the velocity at the top is 17.9. I know the velocity right here is 17. I know the velocity everywhere is 17.9, right? So I don't even need to put an initial on there if I don't want to. But one thing I do also know is I know that the acceleration, since the velocity never changes, the acceleration is 0. Okay. So the first question, let's figure out how high it goes. So I'm going to have to use one of my big three formulas. Yeah, and so let's look at those formulas real quick. It's Vx equals V naught plus AT, We got x equals x naught plus v naught t plus half at squared, and vx final velocity squared equals initial velocity squared plus 2 times a times x minus x naught. Okay, that's everything. Oh, this is a squared. Okay, now so let's look at this, see what will help me figure out how high it goes. I do know the initial velocity, and I do know the final velocity, because right here, I want to figure out how high it goes. The velocity right here vertically is 0. So that helps me figure out how high it goes. So I would say we can use the third equation here. So the height, how high it goes, the third equation. So I'm going to do the final velocity, which is 0, 0 squared equals the initial velocity, which was 15 squared, plus 2 times the accelerations, which is negative 9.8, because we're talking about vertical stuff, times x minus 0, right? Because the initial position was 0. And you just solve for x, so we just do that in the calculator here. It looks like it'd be 15 squared divided by 2 times 9.8, which comes out to an answer of 11.47. So we get an answer of 11.448 really meters. So that's how tall this one went, how high it went. Okay, the next thing, I think it asked for the amount of time or something was in the air. The speed, oh no, that's yeah, the total time it was in the air. Okay, well, I'm going to use the whole vertical stuff for that as well. Okay, now I want the time it was in the air total. So there's two different ways you could do it. You could use the top velocity as being 0, and you could use this formula right here, the first one. And then whatever time you get, it'll only be for half of it, right? So you can multiply it by 2. Okay, the way that I'm going to do it is, how about I use the second equation? Okay, so this will be for time. I'm going to use the second equation. So the final position, it ends up at the floor, right? So I'm not going to use this top velocity on this one. It ends up at the floor. So I'm going to do 0 equals the initial position was at the floor, 0, plus the initial velocity. I'm only talking about vertical stuff, so I'm going to use 15 times time, yeah, plus a half times acceleration, which is negative 9.8, times time squared. And then I can just solve for time here on the calculator. And I would use the solver function on this one, because if you don't, then you're going to have to use a quadratic equation, which I highly doubt any of you want to do that. Plus 0.5 times negative 9.8 times x squared, solve for x, and I get an answer of 3.06. So there we go. Yeah, that's the time. And remember, the unique thing about time is in both of these, the vertical and the horizontal. So when I find time, I found it for the vertical and I found it for the horizontal, which is nice. It goes in both of these givens, yeah? The next thing I think it asked was, how far did it go? Determine the total horizontal distance. Yeah, so how far did it go? Yeah, so we want to figure out this distance here. How far did it go horizontally? And that one's super easy to do. We know the velocity. We know there's no acceleration. We know the time. So we're just going to use the second equation here. Now, here's the reason why you can't use the first or the third one. Acceleration 0, right? So that cancels this term. It just says that velocity is equal to velocity. Same thing here. So this is the only one that doesn't do that. So let's talk about range, which range is the word for horizontal distance. So we're going to be using that first formula. X is what we're looking for. Yeah, we're looking for this thing. Our initial distance, well, it starts at 0, plus our velocity, which is 17.9, times our time, which is 3.06, and then plus, now on this one, acceleration 0, right? So this whole term disappears, so I don't even need to worry about it. So it's just plus 0. So this comes out to be 17.9 times 3.06, and that comes out to 54.8. Yeah, and that's how far it went. Now, the last one here is is asking what is the speed at a certain time. Okay, so let's do the speed at t equals 1. Let's just do it at 1. So I already know the horizontal. What you have to do here is you have to find the vertical velocity at that time and the horizontal velocity at that time, and then we're going to do the magnitude of the velocity squared plus the the y velocity squared, and that'll tell us how fast it was going. Yeah, and I already know the horizontal velocity because remember the horizontal velocity never changed. It's 17.9 the entire time. So I already know one of these. I know this one is 17.9 meters per second. Now I need to get the vertical one. That one does change as it goes up, right? But I can just use this information I have here. I know the initial velocity it had, and I know the acceleration. So I'm trying to get the velocity after a certain amount of time. So I'm going to use this first equation here. So I can do the initial velocity, which was 15, yeah, initial velocity, plus the acceleration, which is negative 9.8, times the time, which is t, which is 1 in my case, because I'm trying to find the velocity I said after 1 second. Okay, so it's going to be 15 minus 9.8 times 1, which comes out to 5.2. So that's the vertical velocity at that time. So now here to get the magnitude of it, you just do x squared, which is 5.2 squared, plus 17.9 squared, and you would just plug that in. 5.2 squared plus 17.9 squared, you get 18.64, and that would be the velocity here. That would be the velocity after 1 second. Cool. That should be everything. Adios.